So we're going to go ahead and talk about a few more of our parent functions that we haven't learned yet. So this first video is going to be just an introduction of the new ones we're adding into our mix. So in order to introduce them though, I want to review some old ones. So the graph x squared, if you remember, is the U or parabola shape graph. So there's a point at 0, 0. There's a point at 1, 1 because 1 squared is 1. There's a point at 2, 4 because 2 squared is 4. And then it reflects over because when you square negatives, you get a positive. Okay, so I just want to show that you're not actually going to graph the x squared graph for your homework or the quadratic graph for your homework, but you will be graphing what's called the inverse of the quadratic, and that is the square root. So just to kind of show you what these look like, now we can't put negative numbers in for x or else we will get imaginary numbers because the square root's like -1. Square root of -1 is I. So we are going to ignore that one and we're going to start at 0. Square root of 0 is 0. So we have a coordinate at 0, 0. Then we'll plug in 1. Square root of 1 is 1. So I have a coordinate at 1, 1. Now typically I go to 2 next when I graph, and you can certainly do that. That's going to give us a decimal answer about 1.4, and that's fine if you want. But the next perfect square that I could plug in is positive 4. So square root of 4 is 2. So we've got that right here. So what you're going to notice, the reason I wanted to show the 2 is it's as if we've tipped our little parabola sideways, right? In fact, if you look, there's 0, 0. I'm going to do it this way: 0, 0, 0, 0. Instead 1, 1, and 1, 1. So those are all the same. But instead of 2, 4, we have 4, 2. So this one was 2, 4. This other one was 4, 2. So inverses of each other will swap the x and the y. So if you were like a key point person in the past, these 3 points on a square root function would be your key points. Also, one more side note, if you see a square root of x, if you see x to the 1/2 power, it's the same thing as seeing the square root of x. So they'll sometimes write it 2 different ways, so just watch out for that. Let's do the next one we're going to do. So just to review, I'm going to show you the x cubed or the cubic graph first. The new graph you're going to be graphing today is the cube root of x. So as a reminder, the cubic graph, you have 0, 0. You've got 1, 1 because 1 cubed is 1. You have 2, 8 because 2 cubed is 8. -1 cubed is -1, and -2 cubed is -8. So there is your little graph right there. So once again, cube root is likewise on the other one is the inverse. So if you did a little table, actually let's do it right here. I was going to do it on the other side. Let's do it right here. So this is the table for the cube root of x, which like the last one, if you see the problem raised to the 1/3 power, it means the same thing as doing the cube root of x. So we are allowed to put negatives in cube roots, so you could do -1, and the cube root of -1 is -1. 0, the cube root of 0 is 0. 1, the cube root of 1 is 1. Now 2, if you do the cube root of 2, you're going to get a decimal. So like we did on the last one, I'm going to switch the order of this coordinate because 2 cubed is 8, so I'm going to plug 8 in, and the cube root of 8 is positive 2. So we get these coordinates. I could also plug in -8, by the way, and you'd get -2 if you want to do that as well. So likewise, this one, it looks like the same graph, the cubic graph, but tipped. So some people call this the stretched S graph because it looks kind of like it's a stretched S. If you're a key point person, as long as you know the shape, the real big key ones you need to know are 0, 0, 1, 1, and 8, 2. So for tonight's homework, what you're going to notice is for both of these, they share these common key points. So you just have to remember the third key point that's different for each one, right? So for square root, it's the 4, 2. For cube root, it's 8, 2. So last little piece of introduction, and then the next videos I'll show examples, is I'm going to just review what each piece does, especially if you are a key point person. So as a reminder, I'm going to start on the right side. The plus k moves the graph up or down, and you'll move it up if you see a plus sign, you'll move it down if you see a negative sign. The minus h, as a reminder, moves your graph left to right, and you always do opposite of the sign. Okay, so if you see a plus sign, you're actually moving left. If you see a minus sign, you're going to move right. All right, and then the C is called your horizontal stretch or compression. It's also called, I call it the X distortion. And that's because it affects the X's. So if you're compressing or stretching the X's, then it's going to affect your graph horizontally. Once again, it's going to do the opposite of what you would expect. And then the A is called the vertical stretch or compression. That's the official name for it. I call it a Y distortion because when you're compressing or stretching your Y values, you're affecting the vertical portion of the graph. So the Y distortion, there's nothing opposite. It's just going to affect your Y's. So if you're a key point person, those are kind of the big main things you need to know.